Alright, these are the notes from class on the last part of our Unit 4 exponentials. Cool. Here we got to figure out how bases, our exponents are set up. 3 is the exponent, 2 is our base. Here's an example of how to work with these. We have 2 to the third power times 2 to the second power. 2 to the third power means there's 3 2's. 2 to the second power means there's 2 2's there, to give us a total of 2 to the fifth power. And a faster way to do that, but you must know both ways, is to add the exponents. So it's not a matter of just adding the exponents. You have to understand why the exponents are added. When you go behind the scenes, you see that those 2 to the third power times 2 to the second power really gives you 5 2's. Thus, you can write 2 to the fifth power. Second example, 2 to the third times 5 to the second. We just leave it. The bases must be the same in order to combine them. Now example 3 has 5 to the fourth power divided by 5 to the second. So you have 4 5's on the numerator, 2 5's in the denominator, and like we've been doing the last few weeks, let's cancel out. And we're left with 5 squared on top, which means we can take those exponents and subtract them to get the same answer. 5 to the... Example 4, 5 to the second power divided by 5 to the fourth. Let's see what happens in that case. Well, there's 2 5's in the numerator, 4 5's in the denominator. Cancel out all those, we're left with 1 over 5 squared. Then if you subtract the exponents, that's 2 minus 4 is 5 to the negative 2 power, which proves that 5 to the negative 2 power isn't a negative number, but it actually gives you that fraction there, which is still a positive number. Okay, the second part. And the second part, about that, they're both equal, they're both correct. We like to write in standard form by not having any negative exponents. Okay, another example, 5 to the negative 2 power times 5 to the second power. You can solve them these two different ways. You can move the 5 to the negative 2 power to the denominator, leave the numerator there, and or you could add the exponents, negative 2 plus 2. Both of them give you 1. Because 5 squared over 5 squared cancel. Negative 2 plus 2 is 0, and anything to the 0 power is 1. So this is proving that anything to the 0 power is 1. Yeah. Part 2 of what we're doing is taking different bases and trying to find out, if they're equal, how to solve for the exponents. Well, here there's different bases, but what we can notice, or should notice, is that 9 is the same or the equivalent to 3 squared. So we can plug in for 9 or substitute for 9 3 squared. So you get 3 squared equals 3 squared in parentheses to the 2x power. That does not equal 3 to the 22x power. That becomes 3 to the 4x power. And then that becomes, because that's 2 times 2x, and I'll show you why in a second. That's it right there. So if you take 3 to the second power, and it's to the third power, that actually means there's 3 of those. 1, 2, and 3. And then what you notice is that becomes 3 to the sixth power. Fast way to do that is multiply your exponents. Now going back to the bottom, our bases are the same, so we look at the exponents. So 3 squared is equal to 3 to the 4x power. Our bases are the same, so the exponents must be the same. So we set 2 equal to 4x. Solve for the x by, solve for the x by dividing by 4, and that gets us to x equal 1/2. Okay, that should hopefully be enough to help you solve the homework. Okay, signing out.